Problem 3, we're given some type of a quadrilateral. We don't know exactly what it is. And we're asked to do some fairly straightforward calculations. The first thing that we're asked to do is to find the slope of line CD. So here's line CD right there. I'm going to look at the 2 points to find the slope. And for part A, I'll say the slope is equal to y2 minus y1 over x2 minus x1, and that gives me negative 2 over 1, and the slope is negative 2. So that slope is equal to negative 2. Then it says show that line AD and CD are perpendicular. I'm going to show that by finding the slope of AD and showing that it's the negative reciprocal. So in your mind, you're already thinking, I know what this answer has to be. It has to be positive 1/2. So for part B, we're going to find the slope of, what did we just say, AD. So I'm looking at A and D, and I'll say the slope is equal to y2 minus y1 all over x2 minus x1. That gives me negative 2 over negative 4, which is positive 1/2. Now right here, since they ask you to show, just doing that amount of work isn't enough. You need to make some kind of statement that says, how about the slopes of AD and CD are negative reciprocals, hence the lines are perpendicular. Just something that says how you knew that negative 2 and positive 1/2 slopes meant that the two lines are perpendicular. Hence the, let me see the one right here, segments, how about that? The segments or the lines are perpendicular. Okay, then it asks us to find the equation of line CD. To me, the easiest way to do that is to use the formula y minus 1y1 is equal to the slope times x minus x1. You don't have to do that. If you want to go through the rigmarole of finding the y-intercept, that's totally fine. I don't like to do that. So right here I know that, what am I doing? I'm doing CD. So one of the points I could use would be point C. That will work just fine. So I've got y minus 1. The slope I found in part A was negative 2 times x minus negative 2 is x plus 2. Now I need to put it in the form they asked me to. So I've got y minus 1 is negative 2x minus 4. I'm going to go ahead and move that 2x over to the other side because I kind of like having that term be positive. So I've got 2x plus y. Now add the 1 over to the side with the negative 4. So negative 4 plus 1 is negative 3. And there's the equation of the line they asked us for in the form that they asked. Next they say that AB and CD intersect at point E. So let's see what that looks like. Here's AB. I'm going to extend this. And CD, and they intersect at some point. Well, I need to figure out what that is. They give me the equation for AB. I've already found the equation for CD, so what they want you to do is a system of equations. They want you to solve for that. I'm going to go over here and say x plus 3y is equal to 6. 2x, that's my equation that I found up above, plus y is equal to negative 3. Let's multiply the first equation by negative 2. So that gives me negative 2x minus 6y is equal to negative 12. We'll add those two equations together, so that gives me negative 5y is equal to negative 15. Y is equal to positive 3. Find the coordinates of E. So the y-coordinate is positive 3. I need to find the x-coordinate by substituting back into one of the equations. We'll use the first one, the one that they gave us, x plus, this one right here, x plus 3 times 3 is 6, x plus 9 is 6, x is equal to negative 3. Now, let's go back and look at our graph. Does that look like it's at negative 3, negative 3? Well, yeah, I guess if I could draw straight lines, that would be exactly right. Find the distance between A and D. So this is just straightforward using the distance formula. I'm going to plug A and D into the distance formula, and the distance is equal to the square root of, subtract the x's, so I've got 3 minus negative 1, 3 plus 1 squared, plus the difference between the y's, y minus 1 minus negative 1, so that's plus a positive, squared, so that's equal to the square root of, we have 4 squared is 16, and 2 squared is 4, so your answer is, sorry, that's kind of all smushing together, the square root of 20. And you can just leave your answer like that. That's an exact answer, or some of you are going to feel better about just going ahead and simplifying that. There's one more part of this question, part F. So I've got that over here. Find the area of triangle ADE. So AD, and E was at negative 3, 3, so let's just mark that. 1, 2, 3, 1, 2, 3, 1, 2, 3, ADE. So this is the triangle that they're talking about. But remember what we know. We know that that is a right angle. We know that the distance between A and D was the square root of 20. So we need to find the distance between E and D, and then we can use 1/2 base times height. I'm going to assume that you can find that distance, and what ends up happening is that the area is equal to 1/2 the base. The height is also root 20, so we end up with root 20 times root 20 is 20, so half of 20 is equal to 10, and then we want to have, I don't know, units squared. Did they tell us it was centimeters? I don't think they did. All right, finish that problem.